Hey, welcome. This presentation is entitled The History of Native Math and Science, and today I'll be your guest lecturer. My name is Dr. Kent Blansett. I'm the Langston Hughes Associate Professor of Indigenous Studies and History at the University of Kansas. I come from 5 tribes, so I'm Cherokee Creek, Choctaw, Shawnee, and Potawatomi descendant. I come from 3 family lines, that of the Blanket, Panther, and of course the quintessential Indian name, Smith, is also in my family line. All throughout Native North America and all the 500 nations and diverse cultures and languages, we have at least higher forms of algebraic expression that are behind our numerical system. Now, early anthropologists, as you can see, at least in these number equations that I posted in the PowerPoint, there's base numbers. And so some tribes only had base numbers of 1, 2, and 3. And anthropologists would say, well, they only know how to count to 3. So they can't be very complex cultures. They can't be very sophisticated people. But what they failed to understand is that we employed multiplicative and additive properties into our mathematical system. So for a lot of tribes to say the number 7, having only the base numbers of 1, 2, and 3, they would say 2 times 3, at least plus 1, equals 7. And that would be a multiplicative and additive system. The other side of this too is that the numbers themselves had greater meanings. For instance, the number 5 for a lot of tribes translates to 1 hand. The number 10 translates to 2 hands. The number 15 translates to 2 hands, 1 foot. And of course, the number 20 is interesting because it translates to 2 hands and 2 feet, or whole being, or human. In other words, there is something important and intrinsic within our numerical systems, and that meant our beings were also a part of this. And of course, we were doing higher algebraic forms of expression just even within our counting systems. There would also be other types of systems employed. There would be dividative systems of counting where division was used. There would be subtractive properties. So sometimes saying the number 5 would be 2 times 3 minus 1 to be able to get to 5 using those base numbers of 1, 2, and 3. So moving on, there was traditionally forms of different forms of counting and different records for accounting for numbers in our mathematical systems. And I want to give you at least 2 examples of those briefly. One is the quipu system. The quipu, which you can see here, is strands at least of knotted cords. And so what the Inca would do, at least in South America, is they would use these cords, or these knotted cords, and the knots and the placement on those cords to be their numerical system. And then they would use strands of color to give that a particular topic or highlight at least the discipline that is to be applied to. So in other words, what these quipus were is they read like books. And those books were using a numerical system to be able to tell those stories and act as historical records. So our history is even rooted in base numbers or mathematical systems. What you can also see is there's another system, which is that of wampum. So if you go to the tribes in the Northeast as well as in the Southeast, wampum was used pretty readily within our treaty belts. And what you can see here is the great Haudenosaunee belt that speaks to the Haudenosaunee Confederacy of the 5 nations, which eventually would then incorporate the Tuscarora. But each of those, at least wampum strands, they had a specific number and counting sequence that they had to follow in the sense of the creation of that, much like the quipu. And you can see this is a round wampum that is right above at least that great Haudenosaunee Confederacy belt. Now, one of the other things that this mathematics had an importance to was agricultural science and or medicine. So we begin looking at this in this kind of great transatlantic trade. I mean, Europe essentially owes a lot to at least native peoples. In Ireland, the potato originates in the Americas. For instance, there was over 30,000 different varieties of potatoes that were grown from South America on up into North America. And the potato revolutionized the economies of Ireland. It meant that you could get all of your nutrients out of that one simple food source, that of the potato. But people for thousands of years, at least in our communities, have been also a part of agricultural science and creations of new, at least crops through the manipulation genetically of those crops themselves. One of the main examples that we can see that in is the example of corn. Now, the original corn itself, or teosinte, was this little blade that looked kind of like wheat. So all the kernels would be at the end of that little wheat grain, and you could get very few kernels off of that. Well, in thousands of years, through at least splicing and pollination and cross-pollination, they were able to produce larger and larger, at least, stalks of corn with more and more grains or kernels on them, and different varieties of corn that would be produced in the thousands of years. So out of this, agricultural science was incredibly important. And how do you plant those crops? How do you harvest those crops? How do you get the most out of that to be able to feed larger populations? Mathematics had to be the root, the language of this science. And of course, medicines. Approximately 90% of our modern day pharmacological science derives from indigenous plants, from all the way from the rosy periwinkle that was used in Ronald Reagan's heart surgery, which is an indigenous derived substance to help with the pain, but also to help with clotting of blood so that at least somebody doesn't bleed out during open heart surgery. All these come from indigenous, at least, plants. So we had a science in regards to agriculture and in regards to plant knowledge, and a very sophisticated knowledge of that. The other thing that it does is mathematics links us with ceremony. It links us to our oral histories, our traditions. And so we can see this in several different examples. And one of the examples I always like to give is this example of Matotipila, which is also oftentimes called Devil's Tower. Now, Matotipila has an interesting resonance with me, because when I was an undergraduate student, there was a professor at the University of Missouri, and he taught this course on geology. And he taught this course to at least 500 students, and there was one native student that was sitting in the audience who happened to be my friend. And while he was teaching this course, he put up the slide of this bear clawing the side of the mountain. And he told this story that, native peoples believed that it was a bear that was, clawing the side of the mountain that created these striation layers within Matotipila as native peoples were being risen to the heavens. And then he said, and he made a joke out of it, and then eventually he said, but science knows that that is absolutely false. It was a volcano that would actually create Matotipila. And so what was horrific about this was the rest of the class laughed at his joke, which belittled our culture. And the student came to me afterwards in tears, and they're like, basically telling me exactly what happened. I got really mad. I remember I called the professor up and I said, I need to have a conversation with you. And of course, I left a bad, irate message. I called, I apologized about it. We eventually got a chance to sit down. And I told him, it's interesting because what does a bear represent? What you're telling or what you told your students, to us, that's a children's story. But there's a science involved within our stories that you're dismissing. And I asked him, well, what does a bear represent in your culture? And he was like, well, what do you mean by that? And I was like, well, bears, you have them in your culture in the sense of teddy bears. Kids go to sleep with them. They're cute. They're cuddly. And what a better reference to a mountain that would erupt than a teddy bear or a bear itself. That what we know about bears is they look docile, they look friendly from afar, but at the drop of a hat, they can erupt in violence. There's no other way of being able to explain how a mountain goes from absolutely looking calm and pristine to something that can be threatening to one's person than to use it as a metaphor for describing a volcano. So essentially, Matotipila as a formation occurs over 50,000 years ago. So someone was there seeing and or witnessing this, and it became a part of our oral traditions that then was handed down generation after generation after generation. And the key thing about Matotipila is that it relates to a larger story. And the story that I'll relay was relayed to me. It was a Lakota story about the origins of Matotipila. And what Matotipila referenced was these sisters that happened to be out. These 7 sisters were out picking berries with their brother. And at one point in time, while they were picking berries, the brother changes. and he transforms into a bear. And he begins chasing these sisters. And the sisters are running and they're fleeing for their lives from this bear. And they don't know what to do. And there's this large tree stump that begins calling to them, please come to me. Come to me and I will protect you, from your brother, this bear. So they run to this treetop. And what this treetop does is it begins to grow. And as it grows towards the heavens and towards the sky, towards the universe, it protects the sisters. And the bear claws at this tree as it's growing and growing. And that's what creates these interesting striation layers, at least in Matotipula. Well, those sisters eventually rise so far that they become a constellation that you can see here. So the Big Dipper, which is also in the Lakota language, the Seven Sisters. So that constellation also relates to Devil's Tower. And it regards another important ceremony, that of Sundance. So every year for Sundance, at least when this constellation of the Dipper, which is like the big spoon that reaches into a fire, that gathers a hot coal that is then fed into the pipe for a pipe ceremony. When these constellations, at least the Big Dipper and then another one, which is Tobacco, basically intersect the sun on the elliptical, that's when they knew it was time for Sundance ceremony. And Sundances would always be at least down around the origin point, which was Matotipula. Another interesting bit of science that is a part of our oral traditions that we can see is the story of at least creation. And for us, it's about the woman who fell from the sky. And multiple tribes have different tellings of at least our creation stories. And then this story, most oftentimes Haudenosaunee and Cherokee peoples, what we do is we tell of the woman who basically is in the heavens and she marries a star person and she has a baby with a star person. And there's this tree that she's told that she can never go near. And she gets a curiosity one day and she begins digging around the roots of that tree. And when she begins digging around the roots of that tree, she sees that there's these stars and there's this whole other planet that's down below. And so she gets curious and she begins at least threading the roots of that tree together. And she makes this long, giant cord and she begins to traverse that cord, climbing down towards the planet. But the cord's not long enough and she falls. And as she's falling, at least the birds come together and they cushion her fall and they take her down onto Turtle's back. And then other animals swim deep, at least in the ocean. They begin bringing up at least the soil, risking their own lives to put soil on the top of Turtle's back. Now, two important things are noted in the science of this one story. One is the concept of gravity. Well known before even Isaac Newton, this idea of falling to Earth, the idea that there's a gravitational pull to the Earth, that the plates, the tectonic plates act like a turtle and are constantly moving. In other words, understanding geology is what we're getting out of each of these stories and out of each of these examples. And mathematics and science happens to be the key to understanding our oral traditions.